This video is homework question 78 to 82 in Chapter 1 in Core Connections Algebra. 78. Which of the relationships below are functions? If a relationship is not a function, give it a reason to support your conclusion. So in part A, is it a function? Well, you can look at a couple different places, but when x is equal to 0, you can see the output below is probably somewhere around -1, but you also have another one when x is 0 here that also goes to 4. So you have one x value going to multiple y values. So therefore it is not a function for the reason that I just stated. On table B, you have x equals -3, 5, 19, and 0. So right there you don't have any repeating x values, so you don't have any x values going to two different y values. You do have, two x values going to the same y value, but that's okay. There's nothing wrong. Think of your soda machine. When you press -3, you get 19 out, and when you press 5, you get 19 out. So it's okay to press two different buttons and get the same value back. So that's all right. So that means, yes, this is a function. Table C, you have 7 going to 10, and you also have 7 going to 3. So you have one button getting multiple outputs here. So this would not be a function, because when x is 7, there's two possible y values. And then part D, you have a graph. You're looking for, is there any x value where you might have two y values? And as you go along here, think about having another x value above or below that line, and it doesn't occur. So therefore, this would be a function. It doesn't appear that there are any x values or one x value going to multiple y values. Question 79, find the x and y intercepts for the graphs of the relationship in problem 78. So on problem A, where are the x intercepts? It looks like it's crossing here and here, and it does look like these are going up by 1s. So we have an x-intercept at -1, 0, and at 1, 0. And then the y-intercept, looks like we have one down here at 0, -1. And it looks like we have another one at 0, 4. And that's why we have two y values, or y-intercepts potentially, because remember earlier, this is not a function. So that would potentially happen. On B, x-intercept, we're looking for when y is equal to 0. So the x-intercept, from the table at least, is 19, 0. And then the y-intercept is when the x value is 0. So you can see down here, when x is 0, y is -3. C, once again looking at the table, we're looking at our x-intercepts. When y is 0, what is x? So we have 2 of those at -2, 0, and at 4, 0. And then the y-intercept is when x is equal to 0, so we have one at 0, 10. On part D, x-intercept, looks like we have one at -1, 0, and another one at 1, 0. And then the y-intercept, looks like there's one below the x-axis at 0, -1. So once again, x-intercepts is where the graph is crossing or touching the x-axis, and y-intercepts is where the graph is touching or crossing the y-axis. Question 80. Find the inputs for the following functions with the given outputs. If there is no possible input for given output, explain why not. So in part A, it actually gives us the output. So this -1 represents the output. This value here represents what we're planning to plug into the function to get that output. So since f of x is the same as y, this whole thing also represents the output. And since we know the output's -1, we can say -1 is equal to 3x minus 7. We're going to add 7 to both sides, divide by 3, and we find that the input is x equals 2 to get an output of -1. On B, same thing. They give us the output, so y or f of x is equal to 10. So we're going to replace the output with 10, is equal to the square root of 2x minus 6. And so we can do a couple of things here. We can look at this problem and determine, what number underneath here. So as I was saying, what number underneath the square root would I need to take to get 10? So the square root of what would equal 10? Well, that would be 100. The square root of 100 is equal to 10. So if you know that, then you can go ahead and just say that, all right, well, when 2x minus 6 is equal to 100, then I know that I can add 6, and then I will divide by 2 to get x equals 53. So that's one way to look at it. All right. Another way is, if you remember in terms of solving square root equations, to undo a square root, the inverse of that is to square it. And so when you square 10, you get 100. And when you square the square root, because they're inverses, they cancel out. So you get to the same point. You can see right here, your two equations are the same. So it's okay to look at it either way, though. But x is equal to 53 when the output is 10. 81. Use the relationship graphed at right to answer the questions below. So is the relation a function? So as you're looking at this graph, starts here, goes up, down, comes back to 6. There's no x value that goes to more than one y value. So is the relation a function? Yes, it is. And then what is the domain? So your domain is your x values. So as you move across this graph, you start at -6, and you hit all these numbers until you get back to 6. So your domain represents all those numbers between -6 and 6. And you can write it out that way. You can use words and say, the domain is all numbers between -6 and 6, including -6 and 6, because you have to include both of those. Or if you were taught the notation in terms of using inequalities, we can use inequalities to write it as well. So once again, you can use words, or you can use these symbols for inequalities. So for an inequality, we want to say that x is less than or equal to 6. So we want values that are less than or equal to 6. But then we want also values to be greater than or equal to -6. And so if I want it to be greater than, then I want my greater than sign to face the x. And so this is one way that you could write the domain using inequalities. As I said, if you're not familiar with that, then you can just go ahead and write it in words and say that the domain is all real numbers between -6 and 6, including -6 and 6 as well. So for the range, same idea, but now we're looking at the y-axis. And so as I go and I start, y is at 0. And then right here, y appears to be at 4. And then it goes back down, 0 again. And then it actually goes all the way down to -4, and then works its way back up to 0. So when you're looking at your y, you're looking at how high the graph goes and how low the graph goes. So on this one, it's between -4 and 4. So you could once again say that all values, the range is all values of y between -4 and 4, including both of those. Or I'll show you once again how to write it using an inequality. So we want all values of y that are less than or equal to 4. But then, so that's all values less than or equal to 4, but we also want them greater than -4. So we'll say y is also greater than or equal to -4. So once again, look at that notation. If that's helpful, go ahead and use it. If not, you can go ahead and use the words to describe what that is. Another thing that can potentially help you out with some of these graphs, if you make a box around how far to the left it goes, how far to the right it goes, and then how far up and down it goes, it kind of gives you that idea as to, okay, the box goes as far as -6 to the left, +6 to the right, it goes as high as 4, and as low as -4. So it kind of gives you that idea as to what your x and y values are. Question 82. What value or values for x will make each equation true? So we have the cube root of x is equal to -2. You can just think about this and figure out what values of x you need to plug in. Or if you want to solve it algebraically, because we are taking the cube root, the inverse of that is to cube both sides. So if you cube the cube root, it cancels it out, and then negative 2 times itself 3 times would be negative 8. And obviously you can plug that back in to check to make sure it works. Is the cube root of negative 8 negative 2? And the answer to that is yes. Same thing here. What's the square root of what is going to give you 12? So if you know that square root of 144 is 12, then you can just answer the question. If you want to get rid of the square root, you have to square both sides and get x equals 12 squared, which is 144 as well. And then on C, we have the absolute value of x plus 1 is equal to 4. So think about this. If I cover this up, what number can you plug in there to make this a true statement? You have two options. You can plug in negative 4. That would work because the absolute value of negative 4 is equal to 4. But then you also could plug in a positive 4. So we also know the absolute value of 4 is equal to 4. So we have a couple options here. And if we do it that way, then when I uncover that, we're saying that this value could equal negative 4 or this value could equal 4. So we'll just set up two equations. X plus 1 could equal negative 4. Subtract 1, that's negative 5. And then on this one, we could say x plus 1 could also equal a positive 4. And if you subtract 1, you get 3. And think about that. If I plug that in, that's negative 5 plus 1. So the absolute value of negative 4, and that's 4. And if I plug in 3, 3 plus 1 is the absolute value of 4, which is equal to 4, which is what we want. So we have two solutions here with an absolute value equation.